And talking about this question, we came across vector question set by set, question by question. And then we stopped over here where we had to talk about a difficult part. This was a difficult, this was one of the difficult question in vectors we had, right? And then the difficulty was we were not given much data. We just wanted to find a ratio which is missing. So the approach, how did we approach this question? Moreover, which year question is this? Do you know? Which year past
Which
paper question is this? 2022, 2023, 4, sorry, 4 is going to be your paper. Yeah, obviously not 2024. Do you know which paper, which year paper this question is from?
no, I'm not sure.
It's
Isn't this a save my exam?
yes, but then it's a past paper question. So this
Oh, okay.
particular page, they don't use what do we call? They don't use model questions. Yeah, of course we have model questions, but these are past paper questions. Find out the year, Alex. Okay, find out the year on your own because you're doing past papers now. You have started doing it. So one of the recent papers, no, not for sure, 2020, 2019, not for sure. One of the recent papers, find out the year. All right. Now, how did we approach this question? First of all, we have to understand we can find out O to N, the vector O to N, in two different terms. We can either take this way. Let me just annotate what I'm talking about. We can either take this way, yeah, or we
Yeah.
can also think of this way. But then we have more than one way. Imagine you can think of this to this, right? Or you can think of this to this. Why not? Also this to this. So you can pick any method, and this is my method. Whatever the method you are taking, you will have to end up having the same answer. That's how the vector works, right? More than
Yeah.
two possible pathways are there. Now, what I picked to do here is I thought of starting here and ending here. Okay, that's my first path. And I thought of starting here and then ending here. That's
Yeah.
my second path over here. So the next thing that I assumed is, since I don't know the ratio, but then I know the total vector O to Y is A plus B, and the total vector M to Z is 3B minus A by 2. In terms of ON, instead of the missing ratio, we are introducing the fraction in algebraic form. The algebra X and then the Y, right?
Yeah.
So that is what we did here. So ON has to be X times A plus B. According to this, the same ON has to be 3B, that comes from here. That's obvious. 3B, that's a solid available data. And then Y times A by 2 minus 3B because we have to reverse it. Yeah, we are taking this pathway, so we had to reverse it, right? We shouldn't
Yeah.
forget that sign. Imagine if you had forgotten that, your rest of the steps will also be wrong, even if your idea is correct. So we had to be very careful about the direction that we're using. So after that, we know this is also O to N, this is also O to N. So we are making them equal to one another. What to do next in order to find out the simultaneous equation to be used up? First step is to find two different pathways that we can take. That way we have two unknowns, two variables, X and Y. So obviously when we have two, we need simultaneous equations to solve them. So I'm thinking of finding a simultaneous equation from this relationship to solve them. So what was our next trick, Alex? I walked you through. So I am now expecting you to tell me that.
So next, you expanded the x times a plus b and
Yeah.
factorized the other section so that you have two equal equations, so you can assume what a and b equal to.
Yes. Now, our idea is we know now for an example, I'll just talk about a different thing. This is not something related to the question. So let's say I have 5x equal 5y. That way x is equal to y, isn't it? We can conclude saying that. Hope you agree.
Yeah.
Okay, now let's say I have 5 equal a plus b. Sorry, 5 times a plus b equal 5x. What is x equal to?
A plus b.
Yes. So I thought of using that idea. Hence, I'm expanding this to get ax and bx. And then I'm rearranging my right-hand side in order to get A times something plus B times something. That A times something is A, y by 2. B times something is factorizing, as you said, taking B out as to be the common factor. We are ending up having 3 minus 3y. From that we know x equal y by 2. Also the same x equal 3 minus 3y. Using that, we are finding what y equal to, right? Which is giving us the missing ratio here. If it is 6 by 7, this has to be the portion of 6. This has to be 1. How do I know if it is 1? I don't have 1 coming over here in my answer.
Which part?
Yeah, see, look at this. I solved this unknown y. Hope you see where I'm annotating.
Yeah.
Okay, I solved that to be 6 by 7. But why did I write this to be 6 to 1 in terms of ratio?
Because it's a total of 7, and since y equals to 6 over 7, the remainder on the other side is a 1.
That is correct. Now coming back, this is now all about solving simultaneous equation, not vectors. Coming back, I'm substituting y's value over here. That gives me what x is, right? You cannot have a doubt on finding that. That's simple simultaneous equation. And you, of course, you did not have a doubt, which is very good, Alex. And moving back, we found the ratio here the same way. We found the ratio here, which has to be 3 to 4. Furthermore, the data gives us ON to OY is lambda to 1. Yeah? But then the ratio that we have found is 3 to 4. So is that all? Can I stop my answer there at that point? No. Why can't I?
Because it wouldn't be correct if you said 3 to 1.
Just because I have a 1 here, but still this is a 4. To make that 4 a 1, I have to divide this by 4, but then I can't do that only there. I'm supposed to do that here. That way, lambda is nothing other than 3 by 4.
Yeah.
Right? Now I'm going to take you to a different question, which is again, in which you have to actually use the similar idea. Okay? Obviously, it's not going to be exactly the same, but similar idea.